Hello there, it's Jay here from Jay's Vintage Junk, and if you haven't guessed already, we're back on with the Opus PC-V Motherboard repair. Now what I've done, I've actually printed out, just to make life a bit easier, you know, like the ISA bus connector and what each pin and everything does. Same with the EEPROM, which is used for the BIOS there, even the 286 CPU there. I printed it out nice and big here so I can make notes on them if I need to, but just makes life a bit easier when we're probing on here. So I suppose what we'll do, I've just realised that I haven't got my postcard here, so let me go and grab my postcard. We'll get that in here and we'll carry on where we got up to previously, which is where I think we was looking for a few signals and try to make some head and a tail of what this board is actually doing. So back. Right, okay, we're back. I've just brought you back quickly because I've not really done that much else, but what I did, remember last time I was messing with this, we went round and we reseated all the RAM sockets, give them a good push down, and a lot of them had chip creep on them. I just thought, I wonder about the CPU, so just quickly with my probe here, I don't actually have the correct tool for getting these out, so I have to be really careful, but a dental probe works quite nicely. Anyway, I popped the CPU out, and it looked all nice and clean here, so I just popped it back in. But when I fired the power supply back up, listen, if I hit reset on the power supply, now that's the most activity we've ever had out of this board. We're still getting absolutely nothing on the postcard there, but like I said, if I press reset on the power supply, which is the same as pressing reset, you know, if I was to short, I've got a screwdriver I can do it with here. If I was to short the reset pins on the board, I'm guessing this is going to have the same effect. Yeah, that sounds like a post beep to me. Now the thing is, I don't know what that post beep means. In fact, let's just make sure. Let's switch the computer actually off, so we're completely down. Let's power back up and see if we get a beep again. No. If I hit the reset, no, it's not doing it again now. Let's try resetting. But that's what I was doing last time I was playing with this, and I said I'd got some strange beeps, so I couldn't get it to do it again. That is basically what it was doing. So you can see if I hit the reset there, you can see it resetting on the postcard. But we're not getting them beeps again. We'll just quickly try pressing round on the CPU again, because all I'd done, the only thing I did, I said, was pop the CPU out and pop it back in, just to make sure it was all, you know, the pins there were in good order. It don't look like it's one for doing it now, but that's definitely most odd. But you heard what the beeps were then. We got was it 2 beeps and then 3 beeps. So what I'm going to do, I'll have a quick look online and see if I can look that up and reference it to Phoenix, because we know we've got a Phoenix BIOS on this, and see if that's giving us any information. It could be throwing us completely in the wrong direction, but so that's about the most activity so far I've actually had out of this board. So anyway, I'll go and have a look online and we'll be back in a sec. Right, okay, we're back, and I've actually managed to find a little bit of information here. Phoenix ROM BIOS codes for hopefully this BIOS. Yeah, because it's 1986/A, and I think that refers to this one here, 1986/A. Apparently a 2 beeps and then 3 short beeps, which is, I think, which is what we're getting. Is CMOS read-write test in progress or failure. Now it gives a note to that as well. that it says that may actually be indicative of an address line issue or a local bus issue. So it's not necessarily a RAM issue that's actually causing that. But what I was thinking, if it's data address lining issue, I left one of the ISA slots here off. Now, I didn't think anything of it at the time, but I'm just wondering now, I'm just thinking off my head, could we have perhaps a broken trace between the top and the bottom of the board? And by the simple fact that we've got that socket off there, we've got that connection broken, and we're not actually getting one of the data or the address lines going all the way through to where it should do on the board. So, because it's not going to take me very long to do, I don't think this is going to give us any trouble doing it. But I'm just going to actually go and stick that ISA slot back on there, just so it's absolutely complete, just so I'm making sure I'm not actually causing an issue myself. So we'll get these, we'll get everything disconnected. So I doubt this is really going to help, but it needs to go back on there anyway, really, doesn't it? Where have I put it? I know I put it somewhere safe. Yeah, I put it in here safe. And it is in reasonable condition, this. We did manage to get most of the horrible corrosion off it. I'm probably completely clutching at straws here, but at least we're getting a beat code off this thing. At least it's a beat code that's actually making some sense. You know, we'll be able to identify what it actually means. There we go, that's gone in. It's nice and tight there. Let's get that over. We'll get that quickly soldered into place. I very, very much doubt this is going to make any difference, but it's worth a try anyway. Let's get some nice fresh solder. Let's get this back on the board. Tell you what I'll do is I'll get this soldered back on and then we'll come back. So you don't need to see me soldering all this back on, do you? You see me do plenty of soldering anyway. So I will come back when I've got this slot soldered back on the main board. So back in a... Right, okay, there we go. We've got the slot back on. So let's just see if that's made any difference at all. I very, very much doubt it will have, but in fact we'll even use that to put the postcard in. I'm still connect the speaker up. If it's going to reach, hopefully it'll reach. It'll just reach. Oh yeah, only just reach. Yeah, I think that'll work though. You can still see all that, can't you? Yeah, you can still see all that. Right, let's get some power connected up and see if that's made any difference at all. To be honest, I'm not expecting it to, but just in case, like I said, we had one of them through holes that wasn't actually making its way all the way through, at least by soldering that back in, it should have made that connection. Right, so let's power back up and see if that's made any difference at all. No, we're still getting a beep. So it doesn't. This is the other thing, that beeps isn't consistent. Sometimes I can get it to beep when I switch it on, sometimes it won't. Sometimes if I play around with it a bit, let's try a different slot, it'll do that funny post beep. There we go. It's doing it now. And it's because once it's on, it's consistent every time I hit reset. It does it. Even if, like I say, even if I hit the reset on the board there, it does it the same. So I think the computer is starting to run, and then it's obviously hitting an error, and I think it is some kind of address error. So what I'm going to have to do now, I'm going to have to go back over all my repair work again and see if I've missed anything, because I think we've probably got a address line or something that's not connected, and that's what's causing the issue. So I'm going to get the tester back out, and I'm going to go back over all the traces that I've gone over previously and see if I can find anything that I've missed. So back in a sec. Right, okay, we are back on with the 286 motherboard. Actually, a couple of weeks have passed since I last worked on this. I was working on it, and it was starting to get on my nerves because I wasn't making any progress at all. And sometimes when you get like that, the best thing is just leave it, have a break and do something else. So I did. I stopped, you know, had a break and did something else, and then got the winter flu, and spent a good 5 days in bed doing absolutely nothing and feeling dreadful. Unfortunately, I'm just about getting over it now, so I thought best thing to do, let's have a crack back on with this. And actually, I've just been having a bit of a play around off camera, and I think I have got a bit of a revelation. I think I may have found an issue. And basically what it is, I was playing about with the scope, really just checking clock signals and things like that, and making sure I had clocks where clocks should be and things like that. And I just happened to check on the little crystal oscillator down there. Now that's used for the real-time clock, and it was dead, completely dead. No sign of activity when I scoped it, when I put my scope probe on that whatsoever. So I thought, right, I wonder if we've got an issue between that and the clock chip. So I went hunting round on the board for the clock generator IC, and it's all the way over here. So we've got our crystal oscillator over there, and then our clock chip is actually over here there. Now, so I thought, right, let's have a look, and this is the part that I actually had to remove. This is where most of the corrosion went. So I thought, right, let's have a check round there. So at first I just had a quick probe round with the scope, and I could see some signals round there. So I thought, oh right, there's obviously nothing wrong there. And I thought, right, let's be a little bit more scientific about this. Let's see and make sure we've got VCC to that chip. And I will get us connected up now. Let's switch on the old multi-tester. You can see that there, can't you? Yeah, you can see that okay. We've got the board all connected up here, and I'll take my probe, I'll switch on. Interesting, sometimes it'll do the beat code, and sometimes it won't. Sometimes if you take the postcode out and move it and switch it back on, it'll do the beat code. It's a bit of an odd thing that sometimes just resetting it will bring it back, but no, anyway. We've got the board on, so let's check VCC somewhere where we know it's going to be, like on that, wherever it is. Oh, it's over there, isn't it? Yeah. Oh, helps if I'm not on the 200 volt on my multimeter. I want to be on the 20 volt range. And there we go, 4.96 volts. So we've got VCC there. Now we come over onto the clock chip. This should be the VCC pin. Oh, now we've got it there now. Now when I tried that the other time, we hadn't got anything there. It was completely dead. We've got 4.89 volts there now. So I'm wondering if we've got some kind of bad connection still round this clock generator IC there, because when I probed that before, I wasn't getting that 4.92 volts there. So actually I wonder if I connect the scope up now. No, you're not going to be able to see it because it's kind of hidden behind here. But I can at least tell you what it's doing. If I connect the scope up now, I wonder if I've got any activity on that crystal. Now in fact, what I'm wondering is this what our actual issue is. Let me get a good ground for this scope probe. Let me clip on the, oh no, that's unclipped. I need a good ground. Where can I find a good ground? See if I can get that back on there. Yeah, I've got a good ground there now. So if I go on the crystal now. No, I've got absolutely no. That crystal there is not oscillating. So what actually I could do with doing is checking, I think it's pin 2 and 3 on this IC. This should be where the oscillator, which is basically the crystal, is connected. So what we need to do is we need to make sure we've got continuity between there and there and there and there, and it could be that crystal's dead there. We could have something wrong with this IC, or we could still have a connection issue around here. As what I was thinking, if that chip's not working, the board won't do anything. The board won't boot. It'll do exactly what it's doing here, because the BIOS needs to be able to talk to basically the little bit of RAM that's in there, which is battery backed up, because that basically that IC isn't just a real-time clock. It's also got the RAM storage for your BIOS settings and things like that, and I think it does a few other things. Like I say, it's not just an IC which is just a real-time clock in a chip. It has got other things in there that the computer uses. So I'm wondering if it can't talk to that chip properly. That's basically why it's not going any further and it's hanging where it's hanging. So let me have a bit more of a probe round and a poke round, and I'm going to just make sure I have basically got continuity. In fact, we can do it now. Let's switch off. Switch that off there now. And let us make sure that we've got continuity where we need to have continuity. In fact, first things first, let's switch that round to continuity there, and let's make sure that we've got a good ground on here, because we know that we've got VCC is that top pin there, and we know that our ground pin is this bottom pin here. Yeah, there we go, that's fine. We're getting, what, 0.7 of an ohm, so that's okay. Right, let's get our other probe, and let's disconnect the one I've got going to ground here, so we've not got any other tracers. And what we'll do, we're going to go off the crystal here, and we're just going to go to the 2 pins and make sure we've got, let's just disconnect them so it makes life a little bit easier for us. And what I want to confirm is we've definitely got a path from the crystal there to pin 2 and 3 on that clock chip there. Let's just double check that it is pin 2 and 3 that we need to be looking at. And get the old phone out, because I've got the yeah, there we go. If we have a look on my phone there, pin 2 and 3 are the oscillator. That's where the crystal should be connected. So let's just make sure we have got connectivity between there and the actual chip. If we haven't, what we could possibly do, just as a quick bodge, is desolder that from there, or use another one and just tack it onto the chip for the time being. But let's just see if we've got continuity there. Right, I'll go on to the first pin there, because we haven't actually had this out of the board. It's one of the... Anything there? No. No. Make sure I'm making a good contact there. Right, let's try the other pin. Right, okay. So that's an issue we've got. Right, we're not getting connection between the crystal, which is over there, and the actual clock chip that's over there. I will do some trace finding, see if I can find where the actual break is, why we're not getting that. if I can, I'm actually tempted just to tack a clock crystal onto the chip there and see if we can actually get the clock to run that way. Anyway, I'll have a quick look at that and we'll be back in a sec. Right, okay, we are back. Actually, quite some time has passed. Chips arrived. I've got one here. I've actually got one on the board already because I have been playing about with this off camera. I've got bad news basically. I think I know what our issues are and it's not good. Basically, let me get this off. I've actually done quite a bit of work off camera, to be brutally honest, and I didn't want to admit what I thought, but I think, unfortunately, I think what our problem is the corrosion on here is actually a lot worse than it initially looks, really. I think it's actually got to some of the internal layers on this board. Essentially what's going on, this is our clock generator IC here. Now, that isn't actually the one that was in here originally. I've got that down here somewhere. Now what have I done with it? Just bear with me a second, folks. I put it somewhere really safe, and then I piled another load of other chips in this drawer, and now, there it is. I thought it'd be pretty obvious because it's got a crystal soldered to it. This is actually the original one. I don't actually think there's anything wrong with it. It's just really, really manky, and I had a known good one. So basically I've put that in there. It's exactly the same. Basically what's happening, the computer, when I initially power it up, I can probe all the address lines, I get some activity, and then it just stops, and it's same as I was saying with that beep code. It's basically getting to the first initiation of the computer booting up, and then it's coming up with a memory, I think it's like a memory addressing error or something like that, and it's just stopping. The clock generator and battery backup for the BIOS there, I don't think it's even initializing. I don't think it's getting that far. I'm getting no activity on it at all, apart from that little bit of activity on the address lines. But anyway, what I was saying, I actually tried tracing out between the clock IC, which is over here, and the clock generator chip there, and I can get one leg of it and I can trace it all the way through over to here. The other leg, now I've actually gone to the trouble of off camera, actually took that IC socket back off the board and had a look, and the leg that I can't find, there's no traces to it. Not on the top of the board, not on the bottom of the board, so it uses an internal trace to go somewhere to like the clock IC here, and I don't think it goes straight there. I think it goes through some of this logic here first and then to the clock IC. I can't find it anywhere. That trace is not connecting. What I did try as a quick test is essentially this is the same chip as in the Dallas real-time clock modules that you get, and in them you've basically got a battery mounted on the top there, and you've got the clock crystal just mounted on the two pins, and them two pins are obviously bent up and round so they don't connect to the thing. So just for a quick test, that's what I did with that. I bent the two pins out of the way there and mounted a clock crystal straight to the IC just to see whether I could get that to actually get the computer to work. No, exactly the same. What I also did, I had a look round here with the scope, and I've actually got the 10 megahertz clock for the computer, nice, running absolutely perfectly. I think it's on that 7407 there. I can see it on a couple of pins there. Absolutely perfect. There is no activity on the rest of that IC. Again with the 40 series IC there, the one that we changed because I wasn't sure whether that was working or not. I think actually that the original one is faulty, because one of the gates on there, it had an input to it but it didn't have anything coming onto the output of it. I've changed it with that new one there, and I am actually getting something from the input, and I'm actually getting a signal on the output now. But that's the only signal I've got on that IC there, and I can't see that's right. I think there's, you know, obviously you've got various different gates in these 74 and 40 series logic chips, and it seemed incredibly wasteful just to use like one gate or two gates. You'd use the other gates for other things on the computer, and I can't see any other activity on them, but I can see pins which go to internal tracers on these ICs. And like I say, I think that's what the problem is. I think we've actually got corrosion damage inside here, and the problem is, if this was an Amiga, say it was an Amiga 4000, an Amiga 2000 or something like that we was working on, and had this issue, I could pull all the schematics for the computer up, and I could literally trace where every one of those pins goes to, and basically find out exactly where it goes on the board, which custom chip it goes to, and I could check through everything. I could even make, you know, bodge wires to replace an internal trace which had gone. Unfortunately, I haven't got a chance in hell of getting a schematic for these boards. That's why repairing these old, you know, like clone PC boards is so much more of a challenge than working on something like an Amiga or a C64 or a Spectrum or anything like that, where there's masses of documentation. Even like the Amstrad CPCs, all the circuits are available, all the old repair manuals are available for them. Stuff like this, there is just no documentation out there really. It's the same with that apricot that I'm working on. I've got exactly the same issue with that. I mean, there might even be slightly more chance with that being a British company and everything, and someone might have something in a filing cabinet somewhere that may emerge one day. For stuff like this was made in Korea, I think. These were, like I said, they were cheap, they were used in lower end budget systems. I just don't think there are any circuit diagrams, any schematics or anything available anywhere really for them. My only chance possibly is if I could ever get a working version of this board and actually use that to trace out and find out exactly what's missing, where it's going, what signals I should have on them chips, and take it from there. But as it's looking, like I said, I honestly don't think I'm going to be able to get this board working. I know it's a bit of a one, because I've not been having a lot of luck recently with resurrecting these old systems, especially when they've got severe corrosion damage on them like this. So what am I going to do? I'm certainly not going to scrap it. I'll put this board away for the time being. I'll probably put the original chip back on. I'll take that crystal off, put that one back in my spares. At least I've got another 4069 IC there. So I'm pretty sure that one is faulty. Unfortunately, it's one of the 400 series chips, 4000 series chips that my Speedmaster can't test. It can test most 7400 logic. It can test some of the 4000 logic, but this isn't one of them, so I can't even just do a quick test in there to make sure that is faulty or not. But I'm pretty sure that is bad, because I did have a signal on there which, like I said, it wasn't getting through to the other side of the gate. Once I changed that, it was. So I think we can say at least that was faulty. Probably due again to the corrosion getting in there. Anyway, I'm going to leave it there for now. Like I say, I hate to admit defeat, but unfortunately, at this time, until something else changes, perhaps I get another board that I can, like I said, work back on. Maybe a miracle happens. Someone will find the schematics for one of these things. You never know what's going to happen. But for the moment, like I said, I'm going to put this away. Possibly put a different motherboard in that computer, so at least for the moment, see if I can get that working. If I do have, although this was planned for another project, but I do have another 286 motherboard here. Actually, it's something a bit more beefy than this one. we might see if we can, perhaps in the next video, see if we could get that working. This does actually fire up and everything, although the keyboard apparently doesn't work on it. That's how I bought this. It does have some battery leakage on it, but I'm hoping with the fact that the board actually does fire up, gets to a boot screen, it's just like I said, it's keyboard error and you can't actually access the BIOS or anything due to that. Might have a look, see if we could possibly get that working. Or indeed, I've got my that Amstrad that I showed that I picked up, the Amstrad it's a 2286, so it's the 2000 series 286 version. I managed to pick up a keyboard, and now it's not a 286 keyboard, but I think, and I'm keeping my fingers crossed, it might work with it. It might be compatible. It certainly has the correct plug, which is not a standard 5-pin DIN. It's like an offset DIN that was used on, I think it was used on the 2000 series, 3000 series and 4000 series of the Amstrads. The AT versions anyway, the XT versions again use a slightly different, I think, different keyboard connector, and they're not directly compatible. But I have got a keyboard that might, fingers crossed, might work with the Amstrad, so we might pull that Amstrad out. Again, a 286. I do really want to get a 286 working. We might pull that Amstrad out and see if we can get the Amstrad working. If we can get the Amstrad working, see if that keyboard will indeed work with it. Anyway, I'm rambling a bit now. Like I say, I'm a little bit disappointed that it's got to this point with this, but let's move on. Like I said, it's not being fun anymore. Just keep trying to chase my tail on this, so I'm going to leave it. Like I said, I'll put it away. We'll work on something new. And like I said, we may come back to this if I get inspiration, or if something else changes, or I get like I said, another board that I can at least use and take other measurements from. So I'll say, hope you enjoyed watching this. Thanks for watching, and goodbye.